Hi everyone, welcome back to the channel. Today we are going to discuss about normal distribution. In the previous video, we discussed probability distribution such as uniform probability distribution, where all the outcomes have same probability. Normal distribution is another type of probability distribution where the graph for probability distribution looks like a bell. It is also called a bell-shaped curve. In this scenario, all outcomes have different probabilities. Before I proceed, I wanted to mention one thing. In the last video, it was discussed that probability function of discrete data is termed as probability mass function and probability of continuous data is termed as probability density function. Since in case of continuous data, we calculate probability as probability per unit length. To avoid any confusion, I will mention probability density wherever applicable. Now, coming back to the normal distribution. Normal distribution is also called as Gaussian distribution. Here, bell-shaped curve has a peak. The x-axis value that corresponds to this peak is mean. Obviously, data, or as you can see, the curve is distributed symmetrically around mean. In such a symmetric curve, mean, median, and mode are all the same. Additionally, there are two more points whose value on x-axis represent standard deviation. These points are also called points of inflection. In general, all the probabilities always add up to 1. For example, if we take the probabilities of head and tails, they will add up to 1. If we take the probability of different numbers on dice, they will also add up to 1. Therefore, we can say the total area under the curve of normal probability distribution is 1 as well. Because data is symmetrically distributed around mean, therefore probability on either side of the mean should be 1 by 2. Another characteristic feature of normal density distribution is that probability of a variable to lie between mean and standard deviation on both sides, or say between both standard deviation, is 68%. Hence, the probability of the variable to lie outside this range is 16% on either of the sides. 68% and 16% on both sides will add up to 100 in total. Another feature is that if x-axis value is taken from mean to twice of standard deviation, or say between twice of standard deviation on both sides, then the probability of a variable to lie in that range will be 95%. This 95% increases to 99.7% if instead of twice of standard deviation we take thrice of standard deviation. Now let's see why normal distribution is so important. When data regarding different kinds of information like height or weight or scores etc. is recorded over large sample of population, then it was seen that its probability distribution resembles a bell-shaped curve and showed all the properties belonging to that of normal distribution. Even if you take the example of the previous video where we calculated the probability of getting heads in coin flips, you can see that probability distribution began to look like a bell-shaped curve with increasing number of flips. This was the case when we were considering binomial probability, only with discrete data, not continuous data. Similarly, it has been observed that if we take a population and we take small samples from that population, like in this case, I have a school and I'm taking 100 samples and now I'm calculating mean of each sample, then the distribution curve of those means around the population mean will also be bell-shaped. The point of the story is if we begin taking the probability distribution curve of any kind of data for a large amount of sample, then it will start showing normal distribution. Now before leaving, I just want to quickly mention cumulative probability distribution. Remember when we discussed cumulative frequency distribution? Cumulative probability distribution is similar in that sort. Here probability of each variable keeps adding up, giving the following graph in case of uniform cumulative probability distribution, and this is the graph in case of cumulative probability distribution of normal density data. This can be used to find the probability of a variable to exist between a particular range or greater than a particular number or less than a particular number. So that's it for today. Thanks for watching. If you learned something from the video, then please like, share and subscribe the channel.